Missing the sick. What happens when the test says negative, but you are actually infected? On the frequentist side, we look at two infected patients. One is caught by the test, and one is missed. The green shaded area under the infected bell curve is power. The probability of correctly detecting a true infection. Power depends on the effect size. The separation between the healthy and infected curves. A bigger separation means the test catches more true positives. But power is fixed. It does not change based on who is being tested. Whether you are an ER doctor's patient or a hermit, the test's power is the same. The Bayesian sees the same two patients, but asks a different question. After a negative test result, how worried should you still be? This depends entirely on your prior. The doctor started at 40%. After a negative test, she drops to 13%. She is still worried. A negative test for a high-risk patient is not very reassuring. The hermit started at 1%. After a negative test, he drops to 0.1%. He is fully reassured. Same negative result. Completely different peace of mind. Now what about retesting tomorrow? The frequentist says, if symptoms develop, the effect size grows, so power increases. A purely mechanical change. The Bayesian says, new symptoms changed my prior. I was at 13%. Now I am at 40% again. Same retest, different reasoning. Recap. Frequentists measure power. A fixed property of the test. Bayesians compute negative predictive value, which depends on the prior. Same negative test, different levels of reassurance. Next time, confidence intervals versus credible intervals. What does it really mean to be 95% sure?